I've talked about how you can use the potential energy of an electric charge, like this one, in an electric field, like one due to this other charge here. How we can use the idea of potential energy in the same way as with gravitational potential energy, by using changes in potential energies to find the kinetic energy gain when, say, a charge falls from a place of higher potential energy to a place of a lower potential energy. Now, but so far I've talked about attractive electric forces between positive and negative charges. What happens? What if we have like charges, like plus and plus or minus and minus? When we have like charges, they will repel, and there would be some change that we need to make, like the minus sign here must become positive. But we can still use this same idea of finding kinetic energy from changes in potential energy. Now let's first try to understand why the formula should change sign. Let's start by thinking about the minus sign here. Now, as we recall from gravitational potential energy formula also has a minus sign, and that's because because potential energy is defined as work done to bring a body from infinity to a certain point, like bring this charge from infinity to here. Okay, to be specific, is the work done by maybe a person, done by some outside, someone outside of this this system of these two charges, or something outside. Not the potential energy does not refer to the work done by the electric force of attraction or repulsion itself. Right, so potential energy is, say, for example, the work done by you or me to bring this charge from infinity to here. And if the force is attractive, then you don't actually have to do the work. Work is done by the attractive electrical force, in which case we have to put a minus sign, because you don't do the work. Work is done by the attractive force itself. So in that sense, it is energy coming from this system. It's like energy being given out by this system, rather than you put in the energy to do the work. That's why we have a minus sign here. And having the minus sign, in this case, it makes sense, because we see that when we use it to find the change in potential energy, we get the correct sign when we want to find the kinetic energy gain, when the charge goes from higher to lower potential, like from here to here. Now what I want to do next is to think about what happens if I have positive charges instead. Now if I have both of these charges positive, then this time, if I bring this charge from infinity to here, bring a positive charge from infinity to here, this time I have to do the work, because there is a force of repulsion, so I have to push against this repulsion in order to get here. So in this case, work is actually done by me, and therefore the potential energy formula should have a positive sign. It should have a positive sign. So that's the first thing that we must know. If we have like charges, doesn't have to be just plus or positive and positive. It also happens when we have negative and negative. Then we should have a positive sign here. So let me summarize this observation. Suppose that I have two charged objects here. Both are positive. And let's say the charge here is Q1 and the charge here is Q2. So there would be a force of repulsion between these two. So this would repel this, and this charge would repel this charge. So what I'm saying is that the potential energy, let me call it U, the potential energy has to have a positive sign. So it will be given by Q1 times Q2, the two charges multiplied together, divided by 4 pi epsilon naught r, where r is the distance in between. So it's basically the same formula that I've written down before, but with a plus sign here instead. So now if I have a negative charge, if let's say I have a positive charge here and a negative charge here, then let's say this is Q1 and this is Q2. Now in this case, they will attract each other. Then the potential energy, now if this is negative, if I call this minus of Q2, then I would need a minus sign for the formula. Like this. And finally, if I have a negative charge here and a negative charge here, if both charges are negative, then they will once again repel each other, so that I need to do work to bring from infinity to here. So let's say this is minus Q1 and this is minus Q2. So in this case, the potential energy would be given by, again, plus Q1 Q2 over 4 pi epsilon naught r. Okay. Now, so from this understanding, we know that it's only when charges are opposite that the potential energy will be a negative number. For like charges, here, this or this, the potential energy would be positive. Now, but it's a bit cumbersome to have 3 different formulas for electric potential energy. So the way to simplify things is that instead of thinking about the symbol Q2 or Q1, instead of thinking of the symbol as a positive number and using a minus sign next to a symbol to represent negative charge, what we can do is to think of this symbol Q2 right? Think of it, well, it's a symbol algebra, so we can think that it can also represent a negative number. It can also represent a negative number. In which case, we would really just need one formula. We just need one formula, meaning that if I just make a formula with a positive sign or with no sign, then I can use the same formula if Q2 really represents a negative number, because when I substitute a negative number into Q2, then Q1 times Q2, assuming Q1 is positive, Q1 times Q2 will automatically give a negative value from this formula. So this means that I can actually forget about these two extra formula. Let's see how this would work. Okay, it's clear enough that if Q1 and Q2 are positive numbers, I will get a positive answer from here. But what if I put in some numbers? What if Q1 and Q2? What if Q1 is, let's say 0.001 coulomb, and Q2 is minus 0.0001 coulomb, like the previous example, and R is, say, 2 meters. I can still use the same formula with a plus sign, but if I substitute these two numbers with the sign into Q1 and Q2, this is what I'll get. Okay, I can default the plus sign, that's understood. So Q1 is 0.001. Now this time Q2, I would put in minus 0.0001, and that would divide by 4 pi epsilon naught. It could be 8.85 times 10 to the minus 12 times R, which is 2 meters. If I calculate this answer, I will get the same result as before. Numerically, I will get 447 joules. And then, because of this minus sign, I would get a negative answer like before. So this is how we could do it. All we really need is one single formula for all cases of whether the charge is positive or negative.